Hey everyone, it's 37th part of making a 4K intro. Today will be a simple, short overview of what has been done. The 4K intro that I was making, I ultimately failed to do anything interesting. Hi Jeffrey. And the thing is, I failed to do a lot of things that I wanted to do, but there was this part where I was like pretty much that I'm happy with somewhat. But anyway, so the final thing that not the final version. I think I will be doing final version in like a couple of days. But like there won't be any interesting and big changes on my part on it. I will be doing an overview of the graphics part of it, and yeah, and this will be the last episode of this making 4K intro thing. So let's watch the final version was like how it was shown on assembly. So as you can see, it was like really short and nothing happened in it. And basically, it looked like very similar to the stuff that like there's not much difference from the like last stream that I was doing on Thursday. And yeah, I'm going to basically overview what I was doing not on stream, because yeah, I decided that I won't be streaming the final development because doing it on stream is really stressful and really distracting, and I felt that I didn't have enough time to finish anything, and like doing it on stream would be like make it just basically impossible. Sorry about that, but yeah. Let me show you like what was going on there. I think when I don't actually remember what I was doing on the last stream, because like was a lot of things that I have done since that, and they like get really like I can't like separate the changes from one another. And what I had to do is basically port the entire architecture to the C version. I didn't have enough time, obviously, to do a proper assembly version, and neither did I like had to do that, because even C version without any serious size optimization was basically fine. So basically in the visuals of that intro that I have shown here to you is where they pack basically into 3100 bytes. So there's like 900 bytes left for the music, but this made me think that it won't be possible to use any available third-party music engine. Neither I had any plans to, because the idea of the thing that I was doing here on stream and in my free time was to make a tool that would allow me to edit shaders, like have this like a multi-stage post-processing shader setup, and have a custom synthesizer, DSP stack-based machine, virtual machine synthesizer, that I would be able to port into 4K and have a really small runtime for it in 4K. I completely failed to make this sound part for this intro in time. So I do have a DSP like engine for sound, and I do have some sounds made in it, but it wasn't like the sound that I was targeting. I couldn't. I couldn't reach it in time, and neither did I have time to like even port what I had to the 4K. So I like maybe like 10 to 20 hours before the deadline, I have visuals that I am happy with. I don't have any I don't have any strong timeline there, so the camera movements are just basically random, and I don't have any timeline, and I don't have music, and I was like trying to do something, and for some reason usually I do get it right, not that right, not that I'm happy with it, but like it sounds somewhat like it sounds okay-ish. But this time around, for some reason, after like hours of experiments, I didn't have any like good sound, so I went with pretty much something random, like to like make I don't know how to say it, like just to make something with the right not like emotion but feeling in it, but yeah, I do think that I failed to evoke that in people, because honestly I do like to get that for myself. I do have to like struggle a bit. So yeah, I consider this one pretty much a failure on like this emotion thing, but graphically I'm pretty much happy with it. Anyway, let's go deeper into like how it's been done. So if you didn't watch any previous streams, there's this tool that that allows me to write shaders, and I will be mainly focusing on shaders because sound is not really interesting here. But yeah, let's do that. So I think I should like show the graphics pipeline here. Let me do this and this and yes and this and this. Okay, and this. So basically what's going on here is this setup where I have no, not that large. I have like random texture. This is like R&D. It is initialized in native code. So there's some basic pseudo-random generator. Yeah, this is the one. So this is just some linear, how do you pronounce it, congruental generator or something. So basically the next random number is the previous, like there's this seed number, and it gets like multiplied and added by some really like random looking numbers. I think one of them should be something like 2 to power something -1 or something, just to get any good results. And some bits from that number, here is like 14 topmost bits, gets to be the next the output random. So it's really cheap and simple and like short. And it gives good enough results for the noise texture, and even for the noise sound, it sounds just fine. Obviously, it's not like security stuff, you can't use that for anything, but yeah, visually it's fine. So there's this random texture, I think it's like 500 by 500, 512 noise size. No, it's even smaller. It's like, yeah, 256 squared. And these textures get fed basically in every shader that needs it. So this texture is static and it's always there. Then there's this main Raymarch program. I'm really bad at writing with the mouse. Raymarch GLSL. Yeah, this is unreadable. Okay, so this is this basic program that does get this input, and it does get the okay, probably yeah, this let me draw it another way. So there's this random texture, and then there's this texture that I call it, maybe there's a shortcut for writing, like for the text tool. No. Okay, I will be writing with my mouse. So this is the texture that I call like Raymarch. Now, why am I so horrible at it? Raymarch primary. I think there's something wrong with my table or a mouse, because like its output is not linear. Primary, and this the texture that is basically also Raymarch, but like reflected. Привет, ГКРК. Ну, его надо подключить, там что-то сделать, возможно, да. Gekorka says that I need a tablet for doing this, but yeah, I don't have anything at the moment, and I also don't feel like I will be able to use it like just natively from plugging it in, and I will struggle with it because I never worked with a tablet before. I think there's like something yeah. Anyway, I won't be doing that right now. So there's this texture, and there will be another one, but I will draw them later. So there's this like Raymarch program, and this is an array. So this is an array of active checked textures. Each of one of these gets its own slot in the like. Each of these textures is bound to the one of the OpenGL samplers. So this is number 0, this is number 1, this is number 2, this is number 3, and there will be like 8 of them, 7 of them. And yeah, this is an array that is also like bound to every shader. There's this header shader, that gets prepended to every single shader that I have here. So this is common stuff that defines this height sorting. This variable gets defined. This is a uniform. This is a uniform that gets defined for every shader, and is like a uniform sampler or something, sampler 2D with all of this stuff. Yeah, I will show it in code, but basically I'm trying to say let you know of the architecture here. So this is a Raymarch shader, Ray GLSL, that reads from this texture. It also reads, there's another array here, I call it F capital, like it has 32 entries, but I end up using like 2 of them or something. I had a lot of plans on it, and I will reuse this tag immensely in my next project that I don't think I will be streaming because, yeah, it's exhausting. But yeah, this was planned to use a lot of these variables to control stuff in the shaders and have rich behavior there. So this and these get fed into ray shader. Yeah, this is all defined in header GLSL. So this is all here, and some like common variables like pi and stuff like that. So this shader, it actually outputs 2 textures. It outputs ray march primary, which is the primary color computed by the primary ray. So it casts a ray, and on the first intersection with the geometry, it calculates the color, and this color gets outputted into ray march primary textures, which basically has like RGB color, and the first component is a distance to the first ray hit, to the first geometry. And it although outputs the reflected ray, so after it has calculated the first intersection, it actually calculates the reflected ray and does one more raycast, calculates another color, and this the secondary, the reflected ray color gets written into X, Y, and Z components of the reflection texture, and component A gets this thing that is roughness. It is material parameter. So I used a physically based shading here, and this roughness is one of the parameters there. So the PBR model here use like metallic, this roughness scene, and albedo. Yeah, I think this is this is it. This is the entire material model there. It's highly inspired by the Unreal Engine 4 model. They have it like a bit more complicated there, but it can be dumbed down to this version. And yeah, it was. I think the most of the code there was taken from the Learn OpenGL tutorial. This one, the code that they have here is, basically what I have there is like rewritten and optimized version of what they have here. I tried to build my own PBR model before that, and yeah, it looks very similar. I think that basically they have streamlined better here, so I was like, I used their model. Or maybe I have some stuff of left that I did myself, but this is not the point. Okay, so this program outputs stuff here, and that's it. This all this program does. Usually the 4Ks out there end up on this program. So usual 4K are just like this thing that like basically fed with time and only outputs one texture that is not really a texture, that is basically the front buffer that is like shown to the screen, not even the frame buffer, it's just directly output to the screen. Well, double buffered, but yeah. And the what I do here is rather more complicated, so let's go there. The third texture is blur reflection 1. It's the first blur of reflection. So this is the blur 1 program, which reads this stuff and outputs this stuff. It doesn't do any fancy thing. I think it's not even parameterized with anything. What it does is, it reads this texture too. It reads this texture because it needs distance. So what it does is it tries to find areas that areas of pixels that belong to one material, to one object and one material on that object, and blurs them. So the idea here is to get a blurred reflection that kind of represents the roughness of the surface. So if the surface is completely smooth, the roughness is 0. It can use the reflection as texture directly, and basically it's mirror-like surface. So when the final color is computed, it will be like the sum of those textures, and it will get direct reflection. But if the roughness is not 0 and some value closer to 1, then it needs to basically it means that the material is rough. It doesn't work as a mirror, but it still gets the color from the environment, not from the lights, but from environment. But it's blurred because of the roughness. So the basic idea is that. And here I'm trying to build these rough-looking blurry textures. So this is basically blur 2. To have more white blur, I say, like because doing the really blur with really white kernels is too expensive, so I do a 2-phase setup. Like it would be even better to do like 4-phase setup, where like there's like just vertical blur and then horizontal blur, which like a common technique. Like this separable blur is even faster, but I've decided that it's too expensive for the 4K size-wise. Maybe it's not, but I haven't tried. But yeah, and it will probably be complicated with this material sameness. So this blur doesn't blur different materials, because if you do that, if you remember, like a few streams ago, I was trying to fix that. It does give like really unpleasant artifacts, and I wanted to get rid of that. So this one here, this program actually tries to avoid like leaking color from one material to another one. Yeah, so there's a blur 2, which reads this one and also reads this one and outputs this one. So basically it's the same. What do you mean by how was the assembly event passed? I don't understand, sorry. Можно спросить на русском, прости, мне не очень понятно. So this was the 4th texture. The 5th texture is a composite color. Composite color. This thing is basically what should color be. Как ассембли прошло. А я не был на ассембли. Я, в общем, основное время ассембли пытался, вот дома бился головой о стену, пытался успеть к дедлайну. И когда я, в общем, написал работу, я ее, ну, то есть я ее, это смешная история, я про это дальше расскажу по-английски. А потом я поехал к друзьям на дачу и смотрел трансляцию с 4К, значит, где-то посреди леса, на маленьком ноутбуке. Это было, соответственно, глубокой ночью, где-то в час ночи, с костром там, ну, в общем, вот это все. Но алкоголя не было. Это было упущение. So, yeah, I was telling that I was watching the assembly. I wasn't at assembly, but yeah, when I submitted the 4K for the assembly, when like I hit the deadline, I will tell you about it like a bit later today. I went to my friends. I got my wife and kids, and we went to our friends like country house, I guess, dacha in Russian, and just we were watching the, not like kids kid went to sleep and wife went to sleep, and but I stayed up with my friend, and we stayed up late, and the 4K compo was like at 1 a.m. local time, and we were like, it's what the like it's countryside. There's like no city light pollution. The stars are visible, and we have like I got this like really little small laptop, and we were watching live stream from the assembly, and there was like this fire, and yeah, it was nice. Anyway. Just sitting there, and suddenly an assembly event. Well, it's not like that suddenly they get it announced. I think they even announced it 1 year prior, so you actually know the dates of the next assembly at the end of the previous one or something like that, if I remember correctly. But yeah, they prepare it really before time. Actually, I think there was like one demo scene, like demo party near Novosibirsk, like a couple of weeks ago, but I didn't know about it before it actually ended, and it like this is really funny. There's like there are two assemblies, assembly winter and assembly summer, but assembly winter is a gamer only event. There are no demo scene events there, so just I'm not interested in it at all. But assembly summer is demo scene. Like they currently they basically economically really targeting gamers, and yeah. Like the most events and most money there are for gamers, but anyway, it still tries to show itself as a demo party, as a major demo scene event, and it's still a major demo scene event. So basically this year, like the demo compo was really strong. There was like 2 or 3 really strong works, like outstanding works, and like a couple more of really interesting stuff. And yeah, the 4K compro was a little bit like mediocre, I'd say, and I even like finished at a really mediocre place there, because like yeah, I'm mediocre, but the 1K compo was interesting. There was like this 1K, the 1K intro that won was JavaScript one, and it was really clever in the way that it completely like it leveraged leveraged the whole HTML CSS thing, which I hadn't seen before. Like usually 1K JavaScript entries are like, okay, we'll get the usual like WebGL setup with shaders and ray margin and something like that. But this time, these guys who did that intro, I don't know them, so they actually completely just disregarded any OpenGL. They just created this layered CSS thing with CSS effects, and it looked really cool. And I thought that this was pretty clever. Like, yeah. Hi, Sir Garbage Truck. Yeah, I'm basically not making an intro today. I'm trying to like tell what my intro was, how it was made, and how it works. That got the 6th place at assembly this year, and yeah. I did work on it on the like series of stream. Like there's were like 36 streams there. Mostly I was like yeah, not really interesting because I was doing a lot of mistakes there, and but okay, my English is not really good. Sorry. Geekercast asked what was the No Spirit demo party called. I don't actually know. I just thought that there was. Yeah, I went to assembly like 3 or 4 times before. My first assembly was like in 2005, and yeah, assembly is great. And actually this year the streaming was like, I didn't have any issues with streaming. Streaming was really super. And yeah, I was watching on crappy 3G internet from the middle of nowhere, like some forest, like 30 or 40 kilometers outside of the city. But still it works like really great. Thanks for yeah, my thanks for everything. I'm actually going to Evoke this year. Like in 2 weeks, I will be. Yeah, in 2 weeks it will be already. Yeah, already ended. How do you say it? Yeah, my English is. I do make stupid mistakes, and sometimes I just get lost in how do I say things. Gekorka says that I need to work on sound. Yeah, I completely, like, I didn't have enough time to work on sound. I made this sound basically 4 minutes before the deadline. And yeah, like literally 4 minutes before the deadline. So yeah, this was completely this like a pile of mistakes of my part. If I did have enough time to get good sound. Like even if I like 10 or 20 hours before the deadline, if I could focus on the sound and have chosen the right road to do the sound, I could have finished something like that sounded better. But I tried to do things that I'm not really good at, and I got like stuck there, and it ate a lot of time, and yeah, I failed at it. So I had to do something really fast, and yeah. Finish. I don't know a word in Finnish, like nothing. I have no idea. Like, well, I do have an idea how it sounds, but I don't like parse it into like different entities that are longer than single phonemes. I don't have an idea what Finnish words are. I was at Evoke a couple of times, and yeah, this is a great party, and I'm really looking forward to going there. I actually planned to go, like considering not planned, I considered going to assembly this year, but it was a logistical nightmare for me. And Evoke is actually a little bit better because they have direct flights from Novosibirsk, the city where I live, to the Düsseldorf, and it is really close to, how do you say it? In Russian we call it Köln. And in English I like this spell like Cologne or something. I have no idea how to pronounce it. Well, so I decided to yeah, Evoke. I had my, and like to go there I had to do a visa, and it was like time consuming and stuff, but yeah. Okay, I'm really looking forward to. Yeah, English gets it wrong, right? Yeah, I will be going to. Gekruka says that, ask where whether I'm going to evoke that at the party. Yeah, I'm going to evoke, and I have everything ready. I have tickets, I have visa, I have a place to stay, and yeah. I won't be doing any stream from there because I basically I think that I will be working on an entry it will be really stressful, and I won't have enough energy in me to do it on stream, and yeah. I think they will be Evoke will have its own stream, so it will be possible to do sofa scene stuff and watch the stream from yeah. Should be a stream from there. Yeah, they have a plan for the do some demo show or something stream. I missed that. I just heard that they will be doing. I heard that they at Evoke they have this weird thing with the trying to bond together several mobile internet providers, doing it at a single stream or something. And I don't think that I know what Synset is. Yeah, VPRNet. Yeah, so those, as far as I understand, they think that you can put a bunch of SIM cards or modems there or something like that, and it bonds those interfaces into logical single one or something. Yeah. But yeah, it's yes, the radio. You mean the radio? Yeah, I know that Synset is radio, but I just misinterpreted that as is there something else? Yeah, that's cool. I do love watching streams. It's difficult for me to go to the parties because I'm 5,000 kilometers away from the nearest party, and the nearest party for me is basically in Japan, actually. But yeah, I really appreciate that you do this because I watch streams mostly. I think that people in Russia who are who do even know what Damascene is are, I do think that they know English good enough to be able to understand what's going on there. I went to Tokyo Demo Fest like in 2012, and yeah, it's also a cool party. I liked it there. I tried to go to the Tokyo Demo Fest this year, but yeah, another logistical and like a family stuff thing. But so I missed that, and I went to Japan like in April or May, and I managed to meet some seniors there, and it was really cool. I was happy about that. The, the most like inconvenient thing, not the distance itself, but the logistical thing. Basically, I have to get a visa to go to Europe, and it until a few years back, it was really complicated because if I needed to go to, like, for example, to Finland, I needed to go to Moscow, spent a few days there to like submit my passport and application and stuff like that, and they take a few days to process it and get my passport, so it really is convenient. And yeah, I did it a couple of times, but it's not like possible like always. It's, yeah, you basically need to have a few days for just the visa thing. Now they have a visa processing center is in here, so I just went to the city, which is like still a minus a day for me, but it's still possible. I'm sorry, I'm not understand like not necessarily the people doing the organizing because of the time and all the technical stuff, and sorry, I don't understand. Yeah, no problem. Like my streams do sometimes get to the like talking with the viewers, chatting and stuff like that. No problem. I was really happy to talk to you. I have a lot of questions from the Gekorka. Sorry. Uh, yeah, Evoke is smaller than Assembly, but Evoke is a pure demo party event where there are only sinners, for what I know, and it's like a really friendly place where you can like go to whoever you want and talk to whoever you want, and yeah, the people are friendly and they are all interested in this thing that you also interested in, and it's cool. Like, I do love this. I do have some people who I know personally. Like, I don't actually interact with people a lot. Yeah, I do have a family. I do have kids. I don't have enough time for anything. I even my friends from like local friends, I do see them like a couple of times per month, and yeah, it's difficult right now. Yeah, I do. I do know Ferris. He's a cool guy, and actually, he is the one who showed me how to use ray marching in shaders. Like in, I think it was 2009 or something, where the party where he he won with the muon baryon thing, and I was impressed. How do you even do that in like 4Ks? And he was like nice enough to even show me the source code, and yeah, from that, this is where I was seeing shaders, like basically I was seeing shaders for the first time, and this technique of like ray marching, yeah. Yeah, and I also watch Ferris streams, mostly in recording, because he streams like from 1 a.m. to 4 a.m. my time. I do sleep at this time, but yeah, when yeah, I know his stuff. He's really cool. Anyway, I will be maybe I will be submitting something for Chaos Constructions now that I have a little bit of tech that I can reuse, but we'll see. Maybe I won't have enough time. Anyway, I have described 4 textures, and I have 3 more left. So the 5th texture is composite color. I don't know, Biscuit. So the 5th texture is a composite color that basically composite from the primary ray and the reflection ray. And this thing actually reads from this texture, and from this texture, and from this texture. No, I can do that. So this one, and this is a program that was called Composite. Composite, and basically it reads this roughness parameter and decides how it will combine this thing, which is always there, with the remaining key. I already told about it. So if the roughness is low, it directly reads from the reflection texture, and you get a mirror-like surface. If roughness is a little bit more, you get like blurred reflection, and at this point it's basically the when the roughness is closer to 1, you get the color from this texture, which is basically really blurred one, where there's like a lot, like just general color in that direction. Is an estimate of image-based lighting, a really poor estimate, really not physically based, but it gets job done. It does look somewhat enough for this. I wanted to do a Raspberry Pi 4K intro. Well, my initial desire, like this winter, was to make a 4K Raspberry Pi intro for assembly using the physically based shading model, because I think it can process that. But I didn't have enough time to even begin working in that direction, so it's still a project that like I still want to do that, but I don't think that I will have enough resources for that in nearest month. So I think that, yeah, after Evoke, I will be pausing my demo scene activity for a while, because I do have stuff that has piled up has been piling up for some months, and I will need to resolve that. So this composite shader basically combines color and writes to this. What do you mean? I don't know by Linux layer under that. So the Raspberry Pi Raspberry Pi thing is I want to completely omit the X11 stuff you don't actually need any X stuff for the OpenGL 3D graphics. There you can directly work with the Broadcom APIs and just basically get a surface, EGL surface for the screen. And if you need an input, you can use like dev input something device files, and no X11, just straight EGL and Broadcom APIs to initialize the output. And of course the 4K basically is an idea, just you DL open the Broadcom APIs, Broadcom libraries, DL sim the function there, which is really cheap, that the strings had packed really well. Load the binary from straight to memory, but this is okay, so there are two options from there. You can just leverage the ARM processor that it has there, and the problem here is like it's really slow. Even the top Raspberry Pi, Raspberry Pi 3, it still has a really slow ARM processor. The most powerful thing in Raspberry Pi CPU, not CPU like this, how do you say that, like COC, system on a chip. The most powerful thing there is GPU. And to use that, it's either like Linux plus Broadcom libraries, or if you go straight from U-boot, straight from the bootloader, you still need a way to talk to it to use that. And I don't think that API there is simple enough to like do it in a reasonable amount of time. There's like this open source driver. I have already looked at it, and it looks like it's just putting the OpenGL calls directly to memory for the GPU to read. Like, it doesn't do any fancy processing for what I've seen, but it's still like not pleasant to do by hand. And so the option one then is like to use only CPU is would look like more an old school thing, but I think that Raspberry Pi can do a lot more of what we have seen. So I had this idea of doing a physically based shading on it, and to get like not photorealistic but really good looking 3D complex 3D stuff there, just to show that it's possible, because I do know that Raspberry Pis can do a lot more that people usually do on it. Usually Gekko asks whether how do you even run Raspberry Pi demo on at a demo party. So usually it's a wild compo where you can do demos on all kinds of things, but the usual requirement there is that you should bring your own hardware. So you submit video how that will be shown to the audience, but you show to the organizers that yes, it does run. This is the hardware that it runs on, and this is how it runs, just to get like confirmation that you didn't fake anything. I'm not aware of any like complicated demos for Raspberry. You can just go to and again, I don't know how to pronounce it in English. Pouet, and check Raspberry Pi demos there. There was no here. Can't find it. Yeah, this is it, and we can just... Yeah, there's some of them. I didn't look at all of them, but ones that I have seen don't look like... they look like a really generic OpenGL rendering with generic lighting models. Maybe I have missed something, but yeah, for what I know now, there's hasn't been any interesting, complicated stuff there, and it's totally possible. Okay, I was working here. Puey. Puey. Do I pronounce it? Puey. Okay. I think I... yeah, at Evoke it will be easier to, like, yeah. Кринтью, привет. French is interesting because they got this their writing like ages ago, and the spoken language has diverged so much from the written one, which is like still the written language is still like from hundreds of years ago, but spoken one is like developed since, and this gets all kinds of messy. Okay, 6 texture. Texture number 6 is the depth of field near field. And also we get a 7th texture, which is depth of field far. I do need to get a tablet for this. And there's this depth of field shader, not A, but O. Depth of field shader that reads from this texture, which also I think has not XYZ, but RGB in first 3 component, the color, and A is a distance. Distance for the first ray hit, for the primary ray hit, and the depth of field basically also it samples pixels around the current pixel that the shader is working on, and writes those ones. It decides whether it samples pixels around the center one, and for each pixel decides to what, how should it contribute to the how do I say it? Well, basically, for current pixel, it decides where it should go, to the near or to the far one. Yeah, I was mistaken there. And then it samples pixels around it, and for each pixel decides whether it should contribute to the current pixel. So the far pixels don't bleed onto the near pixels, but near should bleed to the far ones, and I don't think that I have this thing correctly now, but it's still like and you can still see the artifact there, but it's not that really apparent. And yeah, so, and for all this stuff, where you have color, the color is linear, and this is the final. So this is where the texture array ends, and the final screen is the main post shader by A, not A, post processing shader that reads from both of these and writes to the screen. And this post-processing shader basically decides for the current pixel whether it should Yeah, it basically composites those ones and mixes them. I was really struggling with the mixing of those near and far fields. There, I read a couple of papers on it. One from not the paper, but a presentation from Crytek, I think it was. But they don't explain things in the way that I could understand them. But I did get an idea, like this separate stuff, so that I should separate those things. And I did get another idea that I probably should do another pass here to blur the samples here. So basically now it looks like a lot of points around, but but usually it's not apparent that much, and yeah, I got away with it. But I did plan for another step here. And yeah, I do some kind of simple mixing of them here, and this post-processing I do chromatic aberrations, simple stuff, and tone mapping, and converting to the how do you say it? I forgot the word. The proper color scale for the output. sRGB, not sRGB. How was it called? Gamma correction. I am doing gamma correction there, and I do like this film noise stuff, which is like basically yeah, I do read from the random texture here, but I won't draw the long line to here. And I did have a vignette code there, but I disabled it and forgot to turn it on the final intro because I was running out of time. Yeah, my intro is placeholder. Yeah, and this is pretty much it for the visual part. And it's just, yeah, just like that. So this setup is really unusual for 4K intros. As I was saying before, usually they have only one this program and only one output, and they don't even have a random texture that you can use for the. I actually I do love having a random texture because it gets you consistent results. I did have a really weird looking mistake on big screen because of the hash function, shader hash function. Basically, I did write another like silly mediocre 4K intro a couple of years ago for the assembly, which like was this zoom out thing from the quark stuff to the atom stuff to the like planet stuff. And on the compo machine, the random number, the hash random in shaders, got it that so when you transfer from the ground grass stuff to the planet scale, they started the planet at the wrong place and you just moved to the blue ocean something, and it looked really weird. But the whole intro was looking really weird, and yeah. Kekurko asked whether I would do any like user interface for this. I'm not sure. I'm happy with text-based interface for now, but for music stuff, for sequencing music, I still do want to get and for editing timeline, I still want to do a graphical interface, but I'm not sure. I haven't planned anything yet. Thanks, Sergey Verstruck. For music, I really didn't have enough time. Like the music that is there was done 1 hour before the final deadline, final deadline before the jury starts. And yeah, I didn't use any GNU Rocket. The only third-party thing, except for the OpenGL APIs that I use, is the Crinkler linker and packer, because basically it's really good. It's exceptionally good, and I don't have any chance doing better than that. And yeah. I do have some things that I don't like in Crinkler, but basically just to overcome them is to be... it won't be a much win, like I could win a couple of bytes probably, but like I would have to like re-implement the whole Crinkler, and yeah, I'm not qualified to do that. It's just too insanely good, so yeah. Anyway, to the intro itself. Maybe I should show you the shaders first, and then the native C stuff that places this whole thing together. So this is the how it was Ray March. Yeah. And this is the main Raymarsh shader. It has a lot of functions commented out that that weren't used in the final version. This was the side. One thing another that I wanted to say, that this setup without sound, without anything, only this setup, and I didn't spend enough proper time for make it in further to optimize it further. It took me like 3,133 bytes. So before I started working on sound, it has this size. So this part. And yeah, this thing here basically starts at the main, which is like it. The whole camera movement is this function where I do have like random points for each tick, which is like the time here is not in seconds, is music ticks. So for each tick, it not tick, I think it was like 4 or 16 ticks, like half a bar or something like that. It selects the 2 random points and just does random rotation from one to another. And yeah, it was I did have plan for that, but I couldn't execute it, and it's like ended up looking at how it was looking. Gekirk asks whether to me to show the landscape. I don't think I will be doing that today, sorry. Okay, so yeah, this is just a camera setup where the camera is located and where does it look at, and the look at is also like it's also like moves randomly. And then basically, yeah, the output, it's the raycast function, which I do use global variables a lot here because they read at a lot of places, and passing them is just a waste of space. And so the basic overview of main ends up being really tiny. So the first texture writes the raycast. Raycast is this function that for the ray pose and ray direction casts a ray and writes the color. The color, the first 3 components, and the distance to the third or to the fourth last component. And then I reflect the ray and move it a little bit from the intersection point, that just to avoid registering the same hit point twice. And I also fill the first component with roughness, and Another thing that I do use that is third party is the shader minifier, which is really also really good. Yeah. So I use two tools not made by me, the Crinkler and shader minifier. I did have my version of shader minifier that was basically written in regular expressions, but it wasn't even close to the shader minifier, because basically with regular expressions you can do space elimination, but you can't rename variables and stuff like that. So I ended up using the shader minifier, which is really also really good. It does have quite a few problems that I ended up how do I say, like routing around or something like that. Basically, it doesn't understand the function overloading, and it doesn't have a good mechanism to work with, like I can't tell it properly to avoid renaming specific variables in a specific scope, and this sometimes leads to unpleasant results, I'd say. And it also doesn't understand this setup where you have shaders that consist of several shaders, and if you try to concatenate them, the shader minifier can give you some problems there. But I ended up working around. I did come up with workaround for that, and it ended up fine. So the raycast function, which is called here twice, the raycast function that does calculate the traces array and calculates the color. So basically it starts with the tracing the usual ray Martian code that is where it was. Yeah, this one, which traces the ray alongside the direction and find the intersection with the geometry, which is a usual simple distance function geometry. Nothing fancy there. That is the usual approach here. Probably it could have been better. There are several techniques that allow to make it more efficient and less artifact prone, but I ended up not using any of those because, well, mainly because I forgot, but I didn't had enough time to even remember that. And yeah, so basically I have found the geometry of this thing is made so that you always end up somewhere, and so I don't have a special case for when the rays goes out into the world and doesn't intersect with anything. It always should, at least the closed box, you always intersect with something, so no special case there. And then I set up the colors. I start with, this is another thing that I could have been optimized. In this version I have 3 different materials. I had 5, but I ended up not using them, so I could have been made one of this material, the common one that you start with. But anyway, 0 material, calculate the normal of the intersection point, and pick the material from the material index. The material index is written in the world function with this pick function. It's I have tried a lot of ways of passing material from the world function to the shading code, because this looks not that there's several ways. Do as I do here for trying to alongside the determining the kind of the minimal distance, also like tracking the material index of that minimal distance. And another way is just to have the code similar to this world function in here where you need the material. And yeah, there's no clear winner, but yeah, I ended up using this one. It's still like not really that convenient, but it works. So basically there's like 3 materials. This is, I think, the room material. No, this is the floor material. Do I have? Yeah, ground. This is a ground material. And not much to say there. Just I tried a few values and picked what was looking good enough. And that is for all of these. And yeah, the material 2 is the material for the central object. It's a fully metallic one, and its roughness, I ended up using the wrong roughness value here, because I did have this really cool metallic roughness values that are actually that's ended up being like in this thumbnail of the intro. They look really, really cool, and yeah, I'm sad that I didn't have enough resources to like use all the stuff that I have wrote here properly, because there are a lot of really cool angles, really cool like animations, really cool lighting that yeah, I could have been shown, but okay. And then after I do get the material parameters, I calculate the shading from 6 light sources. Light sources in this demo are point lights, punctual point lines, no area lights here yet. I do think that I will try to write area lights for the next intro that I'm doing for Evoke, and probably I will stream that too in a couple of days. Just this part. I won't be doing streaming on like the whole intro. But yeah, for now it's punctual lights, and this is where I do. So this is where I tried to do a different like shading, like shadow models. I tried to do like simple ambient occlusion, like usual ambient occlusion. I tried to do proper shadows. Okay, sir, garbage truck. Have a good day. Have a good evening. Yeah, I usually stream at Wednesday and Friday, my evening, my 9 p.m. I'm not sure exactly what is like in Europe time. My time zone is Novosibirsk time, like T to like Central European time. Okay. So yeah, this is the time for me right now. So it basically will be 4 p.m. You are in Helsinki. There are 4 hours difference. Yeah, 4 hours. 4 hours. Should be 4 hours. Yeah. We don't have summertime here, like daylight saving time. We don't have that. We just have a single time, entire for the couple of years, and this is really great. So yeah, 4 hours now. So it's your time will be like 5 p.m. Yeah. Okay. But yeah, rest of the world does get a DST, and like most of the rest of the world, and now it's inconvenient for the like, because I have to track time with with people who do change time before, because before that we like the difference was the same. Yeah, DST is bad. Okay, so I ended up using. I tried direct shadows, like when tracing array for the light position, and like ambient occlusion, and I ended up using the combined model where I just trace a few samples of the ray alongside the direction to the light source, and calculate. I don't exactly remember what I did actually did here, because it was like a month ago, and basically it's just an empirically. It's not physically based. This thing is completely unphysical, but it is what looks good enough, and I played with a lot of algorithms, like computation parameters here, and this is what I ended up using. So you can see like this multiplies by 1, which is no operation, but yeah, this because I tried a few values there, and yeah. So this gives you this. I could show you, but I have some troubles with OpenGL here on this machine right now, so I can't show you how it looks, unfortunately. Thanks for the follow, Sir Garage Truck. Thank you. Anyway, so I compute the basically compute like shadow coefficient, and then I calculate the physically based shading with the and the only parameter that I need to pass here is the direction to the light source, and then I might multiply by the light color, the shadow coefficient, and divide by the distance to the light source. And PBR is basically the physically based model, and it's really compact. Basically, this is it. This is the entire physically based model. I do think that it will be possible. It is possible to compact it even more. I do have like this stuff which wasn't in original models, because there's a division, and it is possible to divide by really small values, and it gets you this really nasty artifacts, and I try to avoid that. And yeah, this is the only thing that is. I think this is the only thing that's different. And yeah, probably these 1, 2, just to avoid any zeros. Okay. So yeah, this is really simple. Not simple. I can't. So to understand this, I will need to like open a lot of theory with some integrals, and I can't say that I understand all of this completely, but this is like basically what the industry came up with, to doing like cool shading and really good realistic looking shading, and this is basically the implementation. And yeah, without it you get really like OpenGL 1.1 like this is rendered looking. Okay, and what's is left here is a geometry. So basically the scene, geometry-wise, consists of 3 main objects, which is ground, which is like this rough-looking things with puddles of water or something like that. which is basically like the displacement map of the height, which is also like empirical stuff. I was playing with numbers just to come up with something that looks good enough. And there's a lot of like these cubes, like things that represent something that I had an idea of, like the floor of some hangar or something where just some machines were, but now there aren't any. And yeah, I tried to do that, and then this huge room function, which is basically a geometry of the hangar itself, which is all those how do you say it in English again? Like these columns, not columns. How do you say it? Pillars or something like that, and the roof, and like those roof supports things with holes in them and stuff like that. And although this thing gives you that like eroding kind of displacements where like each is a bit destroyed a bit. Yeah, and this is a slight optimization because it gets really compute intensive and slow when you do that for everything. But if you are close enough to the geometry, I do like do this displacement here. And I won't exactly go into details here because it's messy, and I have actually written this entire function on a stream, like again it was like a month ago or something. And yeah, you can probably watch the making of it with a few reference images found on Google. Yeah, it was a fun stream. And then the object. The object consists of... Okay, let me try to do rendering here. I do want to show you stuff, but I'm not sure that... Okay, can I do like this in the... Okay. Suddenly this doesn't work at all. Okay, this doesn't work. For some reason I do have problems with my OpenGL drivers, and I won't be showing anything today live. So the object consists of this central thing here, which is basically a couple of boxes. There's a couple of boxes and torus around it, and another ring around it, other plane, and there's this thing that wasn't used in the final, but it really looked cool when used properly, and yeah. And then the bound to make sure that the boxes are displaced and they are parameterized, and this is actually used somewhat used in the final. And another thing is these domain manipulations where there are a lot of repeats and mirroring, and it gives you this complicated object from just a few boxes. And there's like these cuts in the geometry, like there are these empty places, I'd say. Yeah, this is the thing that isn't used anymore. And yeah, this is pretty much the central objects in this function. And yeah, this is basically the entire geometry. Really compact, not much of stuff, but it looks cool. Yeah, so this is the ray march. Can I? No. I'm so sorry that I can't show you this. Actually, maybe, just maybe, um, let me do this thing. I will pause stream for like 10 minutes. There will be no stream for 10 minutes, but I will go and try to fix my drivers, and then I return and start showing you stuff here, because I think it will be better if I could show you. So there will be an offline period of like 10, maybe 20, 10, 15 minutes. And then I will go back with fixed stuff, and I will show you the things, how it was made. Okay, so let me do this. Deal. We'll go offline for 10 minutes until 22:50. No. Okay, this is the message. I will just place it, this placeholder on screen, and I will be back in 10 to 15 minutes.